If you look up energy in a dictionary, it will probably tell you something about how energy is required to do things, or how we feel energy. But does this really tell us what energy is? All energy can be traced way back to the Big Bang. Since the Big Bang, the amount of energy in the universe hasn't changed, but it's constantly shifting forms. It's important to understand that energy can't be created or destroyed. Energy can only be stored and released. This is what scientists like to call a conservation law. The two main categories we put energy into are potential and kinetic. Potential energy is somehow stored, and kinetic energy is associated with the motion of an object. All kinds of energy can be put into one of these two categories, but it's not always obvious which one we're dealing with. Take, for example, an ordinary rock. Imagine any rock you've ever walked past just sitting on the ground. If we pick up the rock, then we put some of our energy into the rock, and the rock stores that energy. Picking up the rock is hard work. How much work it takes to pick up the rock is exactly how much potential energy the rock will have. When we let go of the rock, all the potential energy that it has is turned into what's called kinetic energy, and the rock speeds towards the ground. But what if we don't pick up the rock? Does a rock that's just sitting on the ground still have energy? Because it's just sitting there, you might guess that it doesn't have any energy. But it does, and in fact, it has lots of energy. How can this be? To answer this, we need to zoom in on the rock all the way down to the atomic level. At the smallest scale, everything is made of atoms. In many cases, we can think of the atoms that make up solid materials as tiny little balls connected by springs. When we talk about temperature, we're talking about how fast these tiny little balls are moving inside the material. If we make the rock hotter, the balls inside move around faster, which means it has kinetic energy, but it also has a component of potential energy. Imagine trying to pull the two ends of a spring apart. The further you pull the ends, the harder it is to hold it there. When you pull on the spring, you give it potential energy. Solid objects store energy in a similar way. You may have heard that hot objects expand. Well, that's because the spacing between the atoms has gotten bigger, or in other words, the springs connecting them have been stretched, which requires energy. But enough about rocks. Let's turn our attention towards something more interesting. Let's consider a flashlight. A flashlight is essentially a battery connected to a light bulb. The battery contains stored energy, and when we flip the switch to turn the flashlight on, the stored energy in the battery is converted to light. Therefore, the light emitted from the flashlight contains most of the energy that's drained from the battery and is nearly pure energy. Scientists like to think of light as being tiny little packets of energy. While this isn't exactly pure energy, it's one of the easiest ways to conceptualize energy in a raw form. The examples we talked about aren't the only kinds of energy in the universe, but are some simple ways to think about how energy is constantly being converted around us.